Hello class, today we're going to start talking about chapter 2, which deals with trigonometric functions, specifically today of acute angles. Later on we'll talk about angles that aren't just less than 90. But to start with, everything will be less than 90. You'll probably want to have some good notes, some general pictures maybe about some things that could be helpful to you, and some of the terminology as we're going through. Any building blocks that you can learn now will really help in the next section, so keep that in mind. Okay, the first thing that we're going to talk about is just using a right triangle and solving things. And we use what's called SOHCAHTOA. If you haven't heard of that, all the information is on the slide. So sine is always opposite over hypotenuse. What that correlates to is the y over the r value. It's just that the y, x, and r ideas are on a coordinate plane, and then SOHCAHTOA can be used kind of in a general triangle sense. But if you go through all of these, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and then the reciprocals for cosecant, secant, and cotangent. The key here is that you have to make sure you know that you're going from a specific angle. So opposite from that angle is what opposite means, and adjacent is next to it, and the hypotenuse is always the hypotenuse of a right triangle. So you may want to have some of those things written down. At least SOHCAHTOA might be helpful to you as you're going through this lesson. So this question says that here's the trig function, find all 6 trig functions for angle B. Now, you can set up a triangle however you want, but really all you need to care about is angle B has to be in a corner, and C is the 90. So notice I didn't label like A, B, and C, because really I just want to make sure I know where angle B is at, and it's a right triangle. So the key is from angle B, so if I put angle B in this bottom corner here, the 7, which is side length B, so think back to geometry where the side length and angles go together that are opposite of one another. Side length B has to be across or opposite of angle B. That means 24 is A, which is adjacent, and C typically in these questions is always the hypotenuse. You're going to have to do Pythagorean theorem to find C. It's the same idea as the last sections. And then from there, use SOHCAHTOA. So opposite over hypotenuse is sine, so 7 over 25. Cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. The nice thing about the stuff you're looking at today, for example, with these triangles in quadrant 1, is that everything's going to be positive in quadrant 1. So that's helpful. Later on, that's not always the case, but at least for this section, that's at least a nice benefit. The next thing I want to talk about is the relationship between things like sine and cosine. I plugged in sine of 15, 30, 45, 60, 75 and got these answers, and then did the same thing for cosine. It would be helpful to make sure that you plug things in correctly. So try a few of these out. Make sure you get the answers similarly with these decimals when you plug in these degrees. If you notice you're getting a fraction on your calculator, there's probably a way to switch it. So if you have questions about that, let me know. What you should notice here is the one I circled here is sine of 15 is the same as cosine of 75. And 15 and 75 add up to 90, which means they're complementary. That's how sine and cosine get their names. They're co-functions, okay, sine, cosine. Okay, I wish it was like sine's reciprocal was cosine, but it's not. It's designed on the idea that sine of one angle is cosine of its complementary angle. Okay, and what I've said here is sine of A, so sine of an angle is the same as cosine of 90 minus the angle. That's also how secant and cosecant work, and tangent and cotangent work. Okay, so if you know that sine of 60 is something, that's the same as cosine of 30, because 30 plus 60 equals the 90. That's where the cosine cofunction ideas come from. So you might have some questions that deal with cofunctions. They solve for theta. What you need to do is take these two things and add them together, the insides, because you know they have to add to 90. So just take the inside part here and the inside part on the cosine, and just add them together and equal 90, and then solve for theta. That's different than like if it was sine and 1 over cosecant. Those were set equal to one another because they are reciprocals of one another. And we set them up in a way that you could just set them equal to. These questions are going to be complementary, so add them up, set them equal to 90 to find your answer. The next thing I want to talk about is some triangles that you need to memorize and have written down, and make sure you have them somewhere. What you'll notice here is that this is a 45, 45, 90 triangle. This one got cut off a little bit, but let's think about this. If this number is a 1, it's isosceles, so this has to be a 1. And then in Pythagorean theorem, this is 2. That one's really easy to explain to someone. The 30, 69 is a little bit harder to explain, so I'm going off the fact that you'll trust me, and that across from 30 is a 1, because we start with kind of a base case. Across from 60 is root 3, and across from 90 is 2. If you have those two triangles off to the side, we're going to be using those a lot in the next couple lessons and as we move through the rest of the semester. So the sooner that you can memorize them, the better. If we were all in class at all times, I'd probably just have a quick quiz saying, hey, give me these triangles. But make sure that you know them, okay, in all cases, no matter which section you're looking at. We're going to use those triangles to evaluate trig functions. So for example, if I want to find cosine of 45, what I don't want you to do is just say, oh, I can plug into my calculator and find the answer. The expectation is these are what are known as exact values. And all trigonometry classes have these questions where they expect you to know what's going on. Really, the main motivation is that you can use that to help solve application questions or real-world problems, okay, that deal with trigonometry. So you understand the process. That's what kind of the point of a lot of these things are. So cosine of 45, the key is I'm going to find 45 degrees. So here's 45. And I want cosine. Cosine is adjacent, which is this 1, divided by the hypotenuse, and then I rationalize it. For sine of 30 is supposed to be 1/2. Well, sine is opposite over hypotenuse, according to SOHCAHTOA. So from 30, opposite is 1, hypotenuse is 2, so it's 1/2. You're just literally using the triangles. Now, some of you have learned this unit circle idea, and you've memorized things with a unit circle. It does the same thing. But I think the SOHCAHTOA idea with the two triangles will help even when you're not doing exact values. So I would encourage everyone to kind of learn these things this way. I'm not planning to look at the unit circle right now. I could talk about it briefly. We're not going to do a whole lot with it, though, comparatively, maybe to some other classes. The next question says find secant of 30. Now, secant of 30 is a little bit more challenging because SOHCAHTOA doesn't deal with secant. Well, you have to know secant's reciprocal is cosine. So when I'm looking at these questions, I'm just going to find cosine and flip it. So here's 30 degrees. Cosine would be adjacent, which is root 3, divided by the hypotenuse, which is 2. And then I flip it. So 2 over root 3 to find secant, and then rationalize it. Sine of 60. Sine of 60, you have to go from 60. So 60 is up here. You could make another triangle with 60 and 30 flipped, but realize that 60, across from it is root 3. So sine would be root 3 over 2 because across from 60 is root 3, and then the hypotenuse is 2. Notice that sine of 60 is the same as cosine of 30. Why? Because sine and cosine are cofunctions, and their angles are complementary. Okay, the next couple slides deal with just some right triangles that have things embedded in it. I'm going to go from the one kind of perspective, which is just cross-multiplying and similar triangles. There's lots of ways that you can solve these questions, so if you talk to someone else and they have a different option for you, by all means you can use that. Just make sure you're consistent. This question, you'll notice, has two triangles, but in order to solve the second triangle, you have to know stuff about the first triangle. And so the strategy here that I think is easiest to learn when it's new is just using similar triangles. So you'll notice here that this is a 60-degree angle, which means this has to be 30 and this is a 90. Across from the 90-degree angle is 24. So let's say I want to solve for side length A. I'm just going to set up a ratio. A over 24. So here's A over 24. I set that equal to 1/2 because A is across from 30 and 24 is across from 90. So on my main triangle of 30, 60, 90, across from 30 is 1 and across from 90 is 2. So I just say, well, A over 24 has to be the same as 1 over 2. And I just cross multiply, solve, I get A equals 12. To find B, I would say B over, I'm going to use 24, or at least the easiest number that I can deal with. In this case, I could use 12 if I wanted. I'm just choosing to use 24. So B over 24, but now B is across from 60. So now across from 60 on my triangle would be root 3, and across from 90 is 2, so that's why I use 3 over 2. I cross multiply and solve, and I get 12 root 3, because 24 divided by 2 is 12. Now, there's obviously other ways to find that. For example, 24 divided by 2, okay, like 2 divided by 2 is 1, 24 divided by 2 would be 12. There's other ways to find it. I'm going from the route that's brand new for some students, and I think the cross-multiplying technique with similar triangles might be the easiest. Now, knowing that, now that I know A and B, I should be able to use B to find things on C and D. Now, D should be really easy. If this triangle on the right side is 45, 45, 90, so if this B value is 12 root 3, so is D. That one's easy. No cross-multiplying. Don't even have to do anything. They're the same because it's 45, 45, 90. To find C, though, I'm going to use B and C. So B is 12 root 3 over C, which is unknown, equals, well, B is opposite over 45, so now I have to use the other triangle. So 45 would be 1 over the hypotenuse, which is root 2. Cross multiply and solve. 12 times root 6, because the 2 and the 3 multiply together to equal root 6. Your answers here are always in radical form. Okay, most of your calculators don't work with that as well, so you want to make sure that you're working on these things kind of systematically in order to find the answers, and cross multiplying is probably a good route for that. Okay, the second question I'm starting from now the right side, because you have to start with whatever side length's given to you. So notice I have a 7 here. A 7 corresponds to 60 degrees. So from 30 degrees, that would be m. So m over 7. So 30 degree side versus 60 degree side. So m over 7 would equal, on my right triangle here, 1 over 3. Cross multiply, solve. I get 7 over root 3, but I have to rationalize it. That's 14 root 3 over 3. I know it's kind of annoying sometimes to plug those things into your Math Excel homework. Just make sure you're working on that, taking time in order to find that answer. A is found. You could use either the 7 or the 7 root 3 over 3. I'm going to try to use the whole numbers as much as possible. So notice I use 7 again. Okay, so 7 over A, because 7 is the side with 60 and then A is the hypotenuse. So 7 over A equals root 3 is across from 60, and then 2 is across from the hypotenuse. So 60 degree over hypotenuse, 60 degree side over hypotenuse. Cross multiply, rationalize, you'll get 14 root 3 over 3. Now notice, it's just twice as much. And that makes perfect sense because the 30 degree side to the 90 degree side is times 2. But I think this cross multiplying idea explains it better than necessarily just kind of memorizing kind of how to find all these things. Then there's no memorizing involved, and then you can use cross multiplication to find the answer, which is something most students are pretty comfortable with. Once I have A, finding N on this other triangle should be easy because it's a 45, 45, 90. So there's no work involved in that situation. You'll notice to find Q, I set it up just like I did the other questions, but it's kind of weird because it's got this 14 root 3 over 3. That's still okay. I'm going to take 14 root 3 over 3 over Q equals the 1 over root 2 because it's 45 over 90. Okay, with the degrees and the side lengths correspond to that. When I cross multiply it, I'm going to have 14 root 3 over 3 times root 2. You'll notice I put kind of some dotted over 1 because you want to make sure that the numerators go together and the denominators stay together. So when I do that, I'm going to get 14 root 6 over 3. And that kind of makes sense because it should be a times root 2 idea. Now these questions I know are a little bit more challenging. There's not very many of them on the homework, but you need to make sure you understand them. Go through the process, do that cross multiplying. I think that will help you be successful on these questions. We'll continue on with acute angles on our next lesson. In the meantime, make sure you are working on your radicals and simplifying and dealing with SOHCAHTOA with 30, 60, 90, and 45, 45, 90 triangles. Have a good day, everybody.